What is up, chat? I'm really sorry for the delay. Holy shit. I'm sorry. I nearly fell asleep right there. Though it wasn't my fault. It wasn't my fault. Trust. It wasn't my fault in that part, though. Anyways. Hi, everyone. Hi. What's up? How is everyone doing this fine evening, day, night, whatever time it is you're in? Alright. Hi, Marco. Hi, Sophia. Hi. And welcome, everyone, to a collab after, like, God knows how long. And I'm going to be doing a collab with Aceuwa. Unfortunately, I'm really sorry everyone for the delay. I wanted to start like well over an hour ago, but unfortunately she was gone for like the entirety of it. So, you know, it's fine. It is what it is. But finally we can do this. And yeah, why don't we just get started? No, let me call Aceuwa, whoever I spell your name. Oh, I'm sorry. It's just that I barely slept this night. Alright, just hope everything's set up properly and I don't have any more delays. Alright. Alright, here. Hi. Hi. Can you hear me? Is this thing even connected? Hi. Hi!
So, oh my god, hi.
Hi. Hi. How are you doing? God, I'm sorry. I literally fell asleep while I was waiting for you.
You literally what?
Wait, I fell asleep.
Oh, okay.
No, like I laid down for a bit because I was like waiting for so long. Then I just I fell asleep. I gotta pee.
Wow.
I gotta pee. Shit happens.
You gotta pee.
I got EP.
Oh,
you know.
oh, I was like, you wanna piss on Colbert?
What? No.
What? Alright.
Tired, sleepy. Anyways, welcome Ace to my stream. Introduce yourself to everyone.
Oh shit. Hello. I didn't even know I was on stream yet. Okay. Shit.
Yeah, you were.
Wait. Hold on. Let me
I'm
open
on
up your
stream right now, bruh.
I was like, shit.
Anyways,
hold on, I got ads. Hold on.
Damn it.
Alright.
Let's go.
Why am I in the back rooms?
To the no channel. Let's go.
Why am I in the back rooms? Why are we in the back rooms? Hey, you didn't. This was not a part of the deal.
Hey. Where you weren't C was not any concern. All right, trust me. It's not a concern. It doesn't matter where you weren't. You weren't regardless.
But why are we letting C in the back rooms?
Because this is where I am.
What do you mean this is where you were?
Because this is where I am, just where I live.
This is where you live?
Yeah, like every single time I start stream, this is where I am.
Man, where do I sit? On the floor?
But basically. I mean, it's kind of smooth. It's like one of those carpet floors. Like, you know, the entire floor is a carpet.
Trauma. Okay.
Anyways, introduce yourself.
Hello, I'm Aceuwa. I'm also a VTuber. I don't know how to do intros, so, yeah. Yeah.
That's so cool. You go to a job interview, that's how you...
I'm also 19 feet tall.
I'm also 19 feet tall?
I'm 19 feet tall.
I don't think, deaf backrooms can accommodate you, but thank God you came to here in this, chibi form then.
Yeah.
Anyways, why don't we start off the session? I'm gonna be your teacher today. I'll be teaching you VTuber Aceuwa, the C programming language, and as well as a bit of as a bit of computer sciences, because you kind of need that. You kind of need that for programming. So I gotta ask, how much do you know about C?
I see you. That's all I know about C. I see you.
Okay, you know what? Maybe a blank canvas is the best way to start. So you know what? We'll we'll just get through this together, all right? We'll be able to do it. Don't worry. So
yeah.
So, do you really not know anything at all? Like, just nothing comes to mind.
No, nothing comes to mind. The letter C does.
The letter C does.
The third alphabet in
the alphabet. All right. Okay, good thing we're not learning the B language nor the D language, so you know.
Yeah.
Though I think there is actually a programming language called the D programming language. I think it does exist.
The
D programming language. I think it does. I remember seeing it once. Anyways, let me get you a whiteboard that I'll share on Discord and I'll share on stream at the same time, so I can
Yeah,
you
I
know
love
get
a
to explain
whiteboard.
shit. Yeah, me too, man. It helps. Is there a clear button for
Are
the
you
entire
eating?
thing? Oh no, I'm just I just drank a bit of water.
Damn.
Remember to hydrate
Where's my
yourself. It's very
food?
important. Where's your
Nah,
food?
I don't want to hydrate. Just give me food. Where's my Macca's?
There's
Put
only.
the fries in the bag.
Oh, okay. You know, you could just drink water. It is very good.
No,
My
but you
chat
have
would
Macca's
know.
at.
There is no Mac in the back rooms.
But why do you have a hat?
Okay, I told you the war is that I stole it.
Okay, but you should have stole some fries for me.
Well, shit, sorry. I forgot about that part when I fell asleep on accident. Anyways. I'm trying to get the whiteboard clean because I was actually writing down some stuff over here. Though besides the joking, we are here to actually try and learn some shit, you know? Try, it'd be great. You know, all the good stuff, all the good stuff. Alright, let me get the board up and running. Let me I'm sorry, I am not prepared for this because I fell asleep.
He fell asleep.
Yes, I was ippy, as I said. Very
He
ippy.
was EP. He was EP.
Yeah, it happens. Happens to the best of us, doesn't it?
Yeah.
Happens to the best of us. Yeah, exactly. You get EP and
Yeah,
fall
yeah.
asleep, right? Everyone does.
Never.
Oh shit.
I'm too good for that.
What the hell? Oh, it's doing double. Oh, someone followed. Thank you! Thank you!
I legit.
Thank you, Legit Wag. Thank you so much for the follow. That is so epic. So awesome. Welcome. Anyways, here's the whiteboard. Alright. I will share it to you on Discord so you can see it, of course. You don't have to watch the stream.
Holy shit, I just got flashbanged.
I'm sorry. I wish there was a...
My eyes.
I'm sorry. I wish there was a black mode, but there isn't. Alright.
There isn't a black mode? Surely there is. Surely there is. Come on. If you know C, you could...
Yeah, that's not how it works, you know?
What if you get the bucket and do black?
Alright, if that's how you want to do it, then fine. Is there a bucket tool? Is there a bucket tool?
Surely there's a bucket tool.
There must be a bucket
Surely,
tool.
right?
I like how we haven't spoken anything about programming yet, by the way. It's kind of funny.
Yeah, of course. I mean...
Where's the bucket tool? You know what? There is only... Sorry, you gotta live. You gotta live with white mode, I'm sorry.
What a troll, man.
I'm sorry, man. It is what it is. Anyways, why don't we get into some basics? Alright, let's get into some basics. So, we're gonna learn about the zeros and ones and how computers speak, alright? You know, the very beginnings of the beginnings. Oh, on my end, you've disappeared. You're like invisible. Invisible? Real?
I'm invisible? Who's invisible, legit?
Like me? Yo, chat, can anyone see me?
I can see you.
Okay, you know, if your end is fine, then I'm pretty sure they're just trolling. For sure, pretty sure, maybe. Who knows? Anyways, okay, where to start? Imagine like this. You are all the way back in the Stone Age, right? Unga Bunga.
Stone?
Yes, all the way back to Stone Age, yes. All you have is fire, whatever. And, you wanna, math is too complicated. You want something to create something that makes...
What's math?
Okay, I love that spirit, but okay, math, very hard shit. I don't understand any of it. So I want to create some sort of tool. I want to use my human monkey brain to make something that does the math for me. Now, what do we have when we don't have a computer? Nor a calculator.
We have a whiteboard.
Okay, yeah, we have a whiteboard in the Stone Age. Sure.
Do I get a gold star? Can you put a gold star on my head? Please,
you know what? You know what I can do? Wait a minute. Can I?
Yeah, draw a gold star on the whiteboard and make it like on top of my head.
Yeah, yes. Can I like choose a custom color? Oh, do I have to put the thing in? Wait a minute. Why doesn't it give me a color wheel? Please. No color wheel? Really fine. Wait a minute. I'm gonna try to see if I put it properly. I'll just give you a gold star. Yes.
Yes.
I'm trying my best. Hey,
Hey,
gold star.
Hey, look at my gold star, chat.
Anyways,
look at my gold star, and I haven't even done math.
Also,
look at me go.
Someone redeemed a hydrate for Ace, so drink up.
Go get water. Why is it for me, bro?
Go get water. I know we're not on your stream, but go get water. You gotta drink.
Dude, I legit didn't stream, so I didn't get to like hydrate. Alright, I'm hydrating.
I'm sorry, it's the rules. It's the rules.
I don't like these rules. I think we
Hey.
should overthrow. No.
We're the hierarchy. I'm sorry, you're in no stream right now. We're the circus monkeys. They're the audience. That's unfortunately how it works.
Dang.
Anyways, if you're still connected, I'll continue my explanation. So, we have two states, you know, of electricity. There is either electricity flowing,
Positive?
or there is no electricity flowing, just nothing. Right? That's how, you know,
Right.
electricity, electronics all work. There is a state of electricity going through,
I thought we
electricity
just had
not
fire.
going through. We had a what?
I thought we just had fire. I thought we were in the Stone Age.
Well, okay, that was just me being hyperbole. Okay. Imagine we're in the 90s and we don't have a computer yet. We don't have a computer yet.
Okay,
but
we don't have a
do
computer
know-
yet. Okay.
Yeah, but we
No
do know.
computer.
Yes, but we do know that if you click on the switch, light goes on or off depending on the state of the switch. So it's kind of like this. This is the switch. You push it down, and you know, here it connects to the, you know, eventually it connects to a light bulb. You know. Basically, this goes down, electricity flows through, you push it back up, no electricity goes through, it's turned off. So, now, imagine we're gonna use this concept as a means to create something like a calculator, or a computer to compute stuff. So we have basically the state of electricity flowing through, and no electricity going through. Or basically, 0 and 1. You know, or wait a minute, fuck, I don't know how to draw. Here, 0 and 1 for either electricity going through or electricity not going through. Or we have also basically false and true. Now, this is basically the entire concept, the entire like idea that a computer like communicates. And so, we're getting a good start. We now know we have a 0 and 1, right? Cool. We have electricity flowing through, but this is like we're trying to do math here, right?
Math. Yes.
Yeah. This isn't. We just have 0 and 1. Like we need 2, 3, 4. Okay, right? We have 0 and 1. Like that's useless to us.
Useless.
Right. So why don't we just create more? Like, why don't we create numbers from this concept? So we have 0 and 1. So why don't we just add in another digit of 0 and 1? So now we have 2 bits. Okay, in itself, this is 1 bit. A state of either 0 and 1. Now let's add another bit. Now we can suddenly create more numbers. Let's just say 0, 0 is equal to 0.
Yes.
0, 1 is equal to 1.
Yes.
1, 0, because we continue forward, we have now more bits, which is called a bit, a state of 0 and 1, a digit of 0 and 1. This equals to 2. And now we have 1, 1, which is equal to 3. So with 2 bits alone, we can basically create the numbers up to 3. 0 up to 3. Or basically 4, but we include 0, so, you know, -1.
Right.
And so, this is the concept. We're basically, for us to get numbers, we basically add in more bits. Or bits to, basically, bits, which is a state of 0 and 1. And this is what we call binary. The language of binary. The computers speak this. Like, they literally communicate in binary. Maybe a certain sequence of 0s and 1s meets some instruction, and then it reads some sequence of 0s and 1s is maybe a number. It's basically the idea behind a computer. It communicates in 0s and 1s.
Beep boop. Beep boop.
Exactly. Any questions so far?
No.
No? Are you understanding this?
No.
What do you not understand about it?
Why does it equal 2?
Because we're essentially using a sequence of 0s and 1s to represent numbers. Because, you know, we just if we just have 0 and 1, right? Just one bit that can either be 0 or 1, that's just, you know, that's not enough. If we're trying to make a calculator or even have numbers at all, we need more digits of 0s and 1s. And we can use that to map it to numbers, which is what I did over here. So let's just say we have 2 bits instead of 1. A bit is a single digit of 0 and 1. And with 2 bits, we can count up to 4, because here I've shown you. You can see it right here. 0, 0 is equal to 0. 0, 1 is equal to 1. 1, 0 is equal to 2. And 1, 1, and 1, 1 is equal to 3. Now, if we want to go even higher, because obviously we have, like, fucking hell, we have so many numbers. Like, mathematicians even invented this thing known as fucking, what's it called again? Imaginary numbers? Yeah, I don't want to know what that is either. So, 111 is 6. If that's how the math goes, then yeah, probably. So,
Wait, 111 is 6?
That's what Oz over on stream said. But, as I said, I don't know from the top of my head. Usually, I just, you know, use converters or maybe an online website. Because, you know, you can do it with your head if you want to be a smartass. But at the same time, you could just use a website. But this is, I'm just showing this for the sake of understanding it, alright? I'm just showing this for the sake of understanding. So now, imagine what more numbers. So, the answer is simple. We add in another bit. So now, let's add in to our 2 bits. Let's just say we have 3 bits. So let's start off from where we left off. So 111 is equal to 3. So let's start with 100, which is equal to 4. 101 is equal to 5. 111 is equal to 6. So yes, Oz, you're right. And eventually you add in more and more, and you have basically huge loads of numbers. So to calculate, given a number of bits that you have, use the following formula. 2 to the power of n bits. So the reason why 2, it's because first and foremost, we have 2 states, 0 and 1, to the power of the number of bits. So in an example, let's just say we have 2 bits. So 2 to the power of 2 is equal to 4. That is the maximum number we can have, minus 1, because we also include 0. Do you understand? This is just how to calculate the maximum number you can calculate given a single bit. Or multiple bits. Not multiple bits, what am I on about? Is it multiple? Fuck, I'm sorry, my brain is disassociating. Yes, multiple bits. So given multiple bits, this is how you calculate the maximum number. So if we have 2 to the power of 3 bits, hence this number, it is equal to 2 times 2 times 2, which is equal to 8, minus 1, which is 7.
Oh.
So, this is the theory. This is how we have numbers now. This is great. And to do math with these numbers, we literally use how we know math. Do you know how to do math? Do you know how to do very simple math? We're talking plus, minus, multiplication. Wait, can we still throw stuff? I am very sorry to all the no viewers who would love to bully me right now, but I have turned off the throw stuff redemption because I think okay, Ace, please. I have to turn it off. I'm really sorry. Just for this stream, all right? Just for this stream. Just for this stream.
We got scammed, chat. We got scammed.
No. What do you mean? I forgot. I just forgot to announce
it. Okay.
The
teacher.
Oh, fine. Okay, I guess they're doing the second best thing, which is making me hydrate.
Yes, hydrate him. Hydrate him a lot, please.
Yeah.
Drown him. Drown him.
They did that before, actually. Oz almost killed me. On stream.
Please.
He almost did that.
No more math. Just hydrate him.
Anyways, so continuing the good old diagram, right? So now, for us to do math, let's just do the most simple. Let's say with 3 bits, we do some math, all right? Let's say we want to calculate 1 plus 2, right? We already know it's 3. Yes, very good. You know what? Another gold star for you.
Yes, please.
I'll just call this the star corner for you. Oh shit, it has to be a pretty star because you deserve it.
It has to be a pretty star for me.
There. I'll just put here in black.
Yo, can you show us what Alt F4 does?
Aces, stars, Alt F4. What?
What does Alt F4 do?
Oh, it literally emulates Alt F4 on my computer. That's literally what it does, but that's why it's also ultra expensive. Anyways, these are aces stars. Alright, so as we know, it's 3. Now, let's turn this into a binary representation. Binary. So basically, we're gonna like turn these 1 and 2 to, you know, if it were in binary. So, let's just see how we do math with, you know, zeros and ones. So imagine we have 1, which is equal to 0, 0, 1. We're using 3 bits for this example, for us to have space. And now 0, 1, 0, which is equal to 2. Now let's draw a line here. If I've ever done math, you know, I've done this in school a lot when it was a number way too big.
1.
Exactly. Now we quite literally add them together. That's just how simple it is. 0 plus 1 is equal to 1. 1 plus 0 is equal to 1, and then 0. This is equals to 3. Remember? I've shown it before. 1, 1 is equal to 3. Or 0, 1, 1, because we have 3 bits. See, the math adds up. So let's do... Exactly. So let's try and calculate 6, sure. Let's write here 3, which is 0, 1, 1, 0, 1, 1. Now let's do math. 1 plus 1 is equal to 1. Carry 1. We carry the 1. 1 plus 1 is equal to 1. You carry another 1, so you add in here 1. And then you put the final 1 over here.
What the
and
sigma?
That's equal to 6, like earlier. See?
What?
You just carry it. And same thing applies to negation, so on and so forth, and yada yada yada.
Do 0, 1, 1 plus 0, 1, 1 plus 0, 1, 1.
We would have to increase the number of bits because it would overflow.
So it wouldn't just be 1, 1, 1, 1?
It would if you have more bits.
What do you mean more bits?
Because here in computers, when you overflow beyond the size of how... Okay, I'm right now jumping to like variables already. But in a program, you have a variable, let's say it's 1 byte, which is equal to 8 bits. Imagine you go beyond that. What ends up happening is it basically just wraps around. It goes backwards. It overflows. That's what we call it. It goes beyond the limit of the bits that you have. But if we had more bits, then yes, you'd be right. Like if you added in here another one, then yeah, eventually it would, you know, carry over. All right. So now we know how the math works, right? We got it good and so on and so forth. So eventually the fucking something Association of America decided that, hey, let's just say that 8 bits is equal to 1 byte. So basically
I like
2
biting food.
What? Biting food? Yeah, same.
I love that.
Oh, I love biting food. No, if you I'm reading Kennex right now. Kennex, if you come to Newark, New Jersey, you will become a scary story to tell in the dark. What? What does that mean? Anyways, so 2 to the power of 8 is equal to 256 minus 1, so 255. Exactly. That's why you see this number everywhere if you've ever looked up anything about programming. So 1 byte is equal to 255 maximum value you can assign to a byte. It's great. You know, you basically can put any number between 0 and 255. Epic. Now, we have bytes, we have bits. That's very cool. And if we want more size, we should add in more. 2 bytes, basically 2 to the power of 16, because, you know, you multiply the number of bits by 2, because it's 2 bytes. You have 2 to the power of 16, which honestly, I'm not going to do the calculation right now. I'm not paid to. So, this is cool, but we're now slowly transitioning away from numbers. You know, we get a calculator. We can literally do the math. We could just use some sort of like electronic setup to multiply the bits and bytes with. But now, let's just say I want to write a text. I want text. I want to be able to write. Our computers literally have graphic interfaces. We have text. We have all that good jazz, right? Like, you have a computer, you can write a message. You could see text on your screen, right? How do we do that? How do you think we do that? Oh shit, you're muted. I just realized that. Isn't it lovely how this chat treats Null? Yeah, real. Anyways, I'll just answer that question for you. I imagine you're gonna say, nuh-uh. But,
nuh-uh.
Fair enough. Oh, the number to letter language. Not language. It's just conversion. Basically, well, not conversion, more of a mapping. So the way we do it is basically we map a single byte or a sequence of bits to a number. So basically just map it. So this mapping was born known as ASCII, which stands for, give me just a second, only Aceuwa will get to see this, which gave birth to this thing known as ASCII, the American Standard Code for Information Interchange. It's basically a standard for mapping.
Say it again.
What?
Say that one more time.
American Standard Code for Information Interchange.
What does that mean?
It's just a character encoding. It's just a name for it.
What does that mean?
It's basically a code for information interchange, but it's like just fucking this conversion of numbers to characters. You know, in an ABCs.
So if 1 equals A.
Yes, that's an example, but it's basically, they've already mapped it out. They've already worked on all the details. It is called this thing. Yes, it's international. All programs can speak in ASCII. Though, do not ask me about Unicode. That is fucking complicated. Unicode is basically the things that allows you... No, we are not going to talk about Unicode. I don't care how much you talk to me. I'm not going to talk about Unicode.
So, chat, we want to know about Unicode, don't we?
We need to get... We need to get into the C bit. No, we do not want to learn about Unicode. No, leave Unicode away.
Teach?
I don't want to learn about Unicode. I don't know, guys. Okay, one of yours is lost, right? Legit lag. What are you lost about? What did you not get?
He's lost about Unicode. He's lost about Unicode, right, Legit?
He's not lost about Unicode. Tell me. What are you lost about? Legit lag.
Unicode sounds great. Yeah.
No,
sounds like
please.
Unicorn.
I don't
want about Unicode.
What? No, I'm not gonna talk about Unicode, please. Everything, to be honest. I've tried my best to explain, man. We have a state of on and off electricity flowing through it. It lights up a light bulb. So imagine we do some complicated fucking machine that does math given a lot of zeros and ones, turning on and off, flowing energy on and off, which we then eventually call 0 and 1, called bits. And then we added more bits to create the numbers, and then from numbers we go to letters because, you know, mapping. It's okay. It's fine. Just watch the VOD later. Okay, imagine it like this, you know, we have multiple languages. We have English, we have French, we have German, and all of them have some sort of variation in their alphabet. Like, in German, we have the U, we have the in Polish... No. In Polish, we have the weird T. I have no idea what that is. And in Japanese, we have an entire, like, glyph language, so, you know, that is not within the Unicode. Like, if you try to print out Unicode, which is what we basically call, like, this encoding of, like, other characters of different languages, you'll basically get... What is German? You'll basically get, like, on your console. When you print out... When you print out something that is not supported via Unicode. German language? Nah, never heard of that. Never heard of it. SMH. So true, Oz. And so, eventually they created this thing called Unicode, which is essentially the mapping of even further numbers beyond 1 byte, because 1 byte is mainly for ASCII. So basically you need at least like 2 bytes, 4 bytes, or maybe even 3 bytes to basically encode complicated stuff like Japanese.
So is it 8 bytes or is it 8 bits?
8 bits is equal to 1 byte.
Okay. And what's the maximum bytes? Or bits?
As much as your computer can handle it, or depending on what variable you have.
Is it what the thing is? Like the 64-bit window? Ah,
yeah,
right?
Well, that yes, you're kind of getting there, but it's not the same thing. Okay, I'm gonna explain to you. So, as we know, 8 bits is equal to 1 byte. Now, eventually, we're gonna have more and more bytes, so on and so forth. So, eventually, they created this, you know, conversions. It's like kilograms, if you're... You know, from the normal people. You know, we go from grams to kilograms. We go from milligrams to, you know, all that shit. Or we go from
liters.
Milliliters to centiliters to deciliters to liters. And in this case, we go from...
You say centiliters?
Yeah, there is centiliters. CL.
No, there isn't.
There is.
What the hell is CL? I've never heard of CL.
So that's why I can't use EU in Fortnite Creative. Yeah, because they don't support it in the printing, probably.
Wow.
I'm talking to Oz. I'm talking to Oz. He asked
Wow.
about ASCII. Okay, let me search it up. Give me what are we searching up again? Fuck, I had a brain fart. I had a brain fart. What were we talking about again? Huh? Okay, you know what? I'm gonna pretend like I didn't forget, and I'm just gonna continue off from what I was talking about. So we have 1 byte. So we go from bits to bytes, and then after 10,024 bytes
later,
yes, we go to kilobytes.
Kilobytes?
Exactly, like on your computer, a single file. If you create right now a text file, and you write down in there one letter.
Have terabytes?
I don't have terabytes. Well, I do have 2 terabytes of disk, but we do eventually get there. So we go from kilobytes after 1024
What's
bytes.
after terabytes?
Petabytes, and then
what's after petabytes?
yottabytes.
And then what's after that?
Forgot. Would have to look it up. Anyways,
Damn.
and then after 1024 kilobytes, we go to megabytes.
Megamind.
So about Unicode, no legit lag. I'm not gonna talk about Unicode. We'll get there eventually. We'll get to it eventually. So
There's no bolt.
Then from 1024 MB, you know, short for megabytes, we go to gigabytes. And 1024 gigabytes is equal to 1 terabyte.
Would you
and you know, so on and so forth.
Would you cringe if I said gigabytes instead of gigabytes?
If you said what instead of gigabytes?
Gigabytes.
Giga. Why giga?
Because it's like JB. Gigabytes.
Do you also pronounce GIF instead of GIF?
Sometimes.
All right. Are you on stream right now? Are you on stream right now?
What do you mean I'm on stream?
Are you on my stream right now?
Yeah, of course.
All right. Look at it.
No, wait. Hold on. Stop. Wait. No.
Anyways, as I was saying, gigabytes. So you don't worry, they'll find your body tomorrow. So
what?
1024. So this is the conversion. So we go from bits to bytes. So 8 bits is equal to 1 byte, which can be equivalent to basically 255 maximum number, because we also include 0. And you know, I'm not going to do the rest of the conversions, but so on and so forth. 8 bits is 1 byte. 1024 bytes is 1 kilobyte. 1024 kilobytes is 1 megabyte. 1024 megabytes is 1 gigabyte. And 1024 gigabytes is 1 terabyte, and it goes so on and so forth. You can look it up. It's like looking up grams to kilograms conversion. Okay, I gotta get on with my chat, but we gotta continue the lesson. We gotta eventually get to programming, alright? So, back to talking about how we map numbers to text. So, eventually, the American whatever Association of Something Information Interchange created this thing known as ASCII. It's essentially this mapping of 1 byte's worth of numbers to letters. Unfortunately, you can't make up your own thing unless you want to convert it explicitly. So, you know, it kind of sucks. Live with it. And so, they've basically created this thing known as the ASCII table, which looks... Let me see if I could... Oh, wait, is this a valid lookup table? I don't want to consent. Fuck that. I hate consent. Anyways. Let's just go to the part where we talk about letters. Here. This is ASCII.
Consent to Unicode.
So, here, we're gonna... shush, if we're gonna go to Unicode, we need to talk about ASCII first. It's basically the baby's first Unicode, alright? So basically, we map 1 byte to numbers, and this is how it works. The number 65 in Unicode is equal to A. 66 to B, and so on and so forth, and then it goes all the way up until 97 to continue with lowercase a, and goes all the way down. Drinking time. Thank you, Oz. You guys do exhaust me quite a bit. If I was a teacher, I'd probably be dead by now. So, this is Unicode. We're basically mapping 1 byte's worth of numbers to data. So 65, the number 65 in one byte is equal to the uppercase A. And it goes so on and so forth. So basically all the way down to alphabet, and then beginning with, 90 something, you get, you get eventually, lowercase a, and so on and so forth, as we saw earlier. So now we have text. We were able to map numbers to text, which eventually... Yes?
Does the ASCII go for, like, all programming languages?
Yes, it goes for all programming languages.
Even Unicode?
I'll get into Unicode, and Unicode is not a programming language. It's a mapping that goes beyond 1 byte, which we'll talk about now. So eventually,
ASCII code 1 byte.
So ASCII is basically just for the Americans because they have no originality. Basically that. Like you can't print emojis. You can't print characters that are not different from a different language from English if you're printing an ASCII. Which is eventually, eventually the Americans realized as computers became more common that this is a problem. We need to be able to, accept more numbers, more letters into our system. No emojis, boo. Yes, it was a thing, but don't worry, they fixed it. So, eventually they created this thing known as a Unicode. I'm not going to talk about every previous iteration because that is even more of a pain and I was not taught to teach that. So, they eventually created Unicode, which is essentially an extension to ASCII, which basically increases the 1 byte limit to God knows how much, depending on what character you're printing out. Remember how me and Ace, this is something you guys don't know, but I worked with Ace on a program. I'm not going to say anything else besides that, it was a program she needed to do. And I basically went insane trying to figure out how to print out an emote, a character that existed outside of ASCII. Yes, I basically went insane. So basically, Unicode is essentially the mapping of more bytes to characters. Except it's very complicated to do in a programming language. Like, for example, in C, I had to literally look through the fucking Windows 32 library to find out what I had to do. It was painful. Anyways, I don't want to talk about Unicode anymore, because now, let's get into coding. Let's get into coding. It's time. Alright. Let's get right into coding. We've talked enough theory. You know what binary is. This is how computers speak. They speak in zeros and ones, and we just, we basically map it to think the shit we understand. Alright, open up your Visual Studio Code and share it on... Yes, you.
Me?
Yes, you. We're both gonna have it open. I'm gonna have one to make sure I'm also assisting you as well. But yes, you're gonna be the one writing now. You thought it was just gonna be yapping the whole time? Unfortunately, that's not how it works. Not in this economy.
Can I use an online one?
No.
A browser?
Bro, we literally went through this before, didn't we? Like, I really asked you if you had your compiler and shit. Are you real?
Beep boop. Online compiler it is.
Okay, you know what? If that's the case, I can't even know. You know what? It's gonna have to be me. Alright, okay guys, I guess Beeble's literally gonna be, what's it called again in gaming? What's it called again? You know when you, it's not assist, you just watch someone sit something gaming, whatever. It's basically just sit coding, whatever, I don't know. Anyways, I'll be the one coding, I'll just be showing it to you, Ace, on, I'll just be showing it to you. I'll just be showing it to you, Ace. My screen.
Beep boop. Beep boop.
Don't beep with me, please. Alright, give me a second. Let me launch up my Linux.
2, 3.
Alright, it's called Vivo? No.
Vivo!
No, please. Okay, let me just do my shiz, please. Let me open up a folder. I gotta... Wait, why the fuck do you not... Really? I'm gonna have to like put in the specific path and everything? God, fuck me. Alright, okay, guys, I'll be coding in, Aceuwa's stead, so, you know, I just hope she remembers everything we're talking about today. Alright.
Yeah. I mean, I am streaming something to you if that helps, but...
I told you that I will not rely on an online compiler that literally does not behave like an actual compiler.
But...
There are a lot of things that only an actual compiler will do. Anyways, let's get onto it. I will share to you guys my... Give me a second. My Visual Studio Code. Woo! Scary code interface. Woo! Spooky. Whatever. Alright. Alright. I got it on screen. Can everyone see it correctly? Can you see it? Do you want me to share it directly to you, Ace, or we're gonna watch it from my stream?
I'll watch the stream. I'll watch it from the stream.
Alright, epic. Then let's get into the the most basic C program a person can physically do. The most basic of basics. What? Where the fuck was that played from? Are you using your soundboard? Okay. Anyways, code main.c. This is the command to basically code, wait, why the fuck are you opening up another Visual Studio instance? Fuck me, it isn't working properly.
Whoops.
Great. Okay, you know what? Let me just... Yep, alright. I'm showing the wrong thing. I hope that doesn't run for longer than it has, because I may get copyrighted because of it.
Nah.
Alright, thank the Lord then. Alright. Why is it just showing this again? Bro. Oh! Alright. Okay. Fuck it. I just will directly use the interface. I like using commands. Okay, you know what? No more soundboard for you. Alright.
No!
Alright. So, let's create right here a new file. I'm gonna call it main.c. That's usually what we name our entry file. It's basically the file the entry file. Basically the one that gets called. This is your entry point. So, the way you start is you write down sharp include stdio. Then you write down this following function known as int main. Open curly bracket, close curly bracket, return 0. Now, there's a lot to you know, to absorb. But don't worry. I will explain it.
I have a request.
What?
May you zoom in a bit?
Well, you can't see it? Oh, well, fair enough. Let me see if I know what the thing is. Does this look better? I zoomed in.
Yes. Way
better?
better.
Alright.
Way better.
So, this is the syntax of C. Syntax is basically, it's just a name for basically the style of the language. This is how it looks like. This is how, you know, the language looks like. This is, you're basically going to see this everywhere. So, what I did up here is I did a sharp include, which is basically a preprocessor command as your compiler is compiling the thing. The compiler is processing the code. It basically reads this and says, hey, alright, I'm gonna now go to this file. This is a file on your computer. You can literally go there by pressing control click. It sends you to stdio.
What? That's so cool.
This is literally a file, and sharp include is basically a command to, hey, I want you to go to this file, copy all of its contents, and paste it right here. And what basically is within stdio is a bunch of functions that you can call from the standard library. Like, for example, printf, which prints something to your screen. Like this. Printf hello world. \n, I will explain what that is later. Oh, that's why the quality of your streams was so ass. I was watching with 360p turned on. I don't know why. Are you serious, Oz? Are you serious? My word. Alright. And this is the syntax of the basic entry function. When you create a C program, and usually in almost every other language in programming, has a main entry point. Basically where everything starts. In C, it's called main. In C++, it's also main. In C#, it's within a class and a function named main. But this is basically where your entire code starts. And the way it's defined usually is with the type of the function, the type of the entry point, which is int. It returns an integer. The function will be named main. And usually it does take some arguments, which is what you put in here. Basically things you want the function to get through. Usually I'm going to get into the arguments of the main function later. But there is something you can put in here for the main function. We're not going to talk about it just yet. And here you put in your code. You do, I don't know, maybe some math, like 2 plus, like, I don't know, 1 plus 2. And you end it here. It can really do that. And, yeah. Hello, world. Why are you with the heartbroken Oz? You know what? Fuck it. Hello, chat instead. There. It's the upgraded streamer version of the Hello World program.
Can you add an exclamation mark?
Exclamation mark? Yeah, sorry, I forgot. It's very important. It looks way too,
Yeah.
way too generic. Alright, so, on Linux, and if you have the C compiler, you usually write down the following command. JCC is the C compiler. You put in as input the C file that you want the compiler to compile. A compiler is a program that reads in code and poops out something your computer can run. SMH Vivunk didn't get the new memes. Where I don't know any Hello World memes, man. Fucking hell. Anyways, it takes in a C file and it exports a executable, something your computer can run. .exe, or in Linux's case, it's a .out file. So right here, I write O, which stands for output, and I maybe call it main.out. And then it's compiled. Right here, it exists. Here is the file. It's really just binary. It's zeros and ones, machine instructions that your computer understands. And so, for you to run the executable on the command line, or on Windows, usually you just double click the executable, but in the command line on Linux, you put // main.out. See, and there appears hello chat. Hi chat. Now then, any questions so far?
What happens if you add 10 new lines?
What do you mean 10 new lines?
Like on the hello chat.
On the hello chat? Oh. Like this?
Jeff
I'm pretty sure it doesn't
Bezos
even actually process it.
Everybody
Also, someone's
praise
getting
Freaking
ad L Brokey. Don't worry, I'm pretty sure these guys are tired anyway of this. Alright, so it doesn't do anything. If you do this, it's just, you know, it will still give you the same out. Well, okay, you know what? It'll just say this, apparently. It just can't process it properly if it has a space.
Oh.
So, you know, you gotta put everything in line unless you specify that you will have, you know, multi-line character string, whatever. Like this. I think this is how you put it, right? Or is it only C++? It might just be just a C++ thing. But yeah, no, you can't put a multi-line. But if you do want more lines, more backlines like this, you just do this. Wait a minute, shit, wrong. /n, /n. Now, if you do this, you get a shit bunch of enters, basically. Alright, let me explain what this program does. So it does printf, which prints to the console, which is right here below us. Can you copy and paste? No Vivo is now live streaming games plus demos, playing live indie games. My passion. I ran out of. Okay. I hope you. I don't know. I hope something. Anyways. So what I wrote over here is a string. A string is basically a list of characters. As we talked about before, a single byte. Wait a minute, sorry, I didn't write down the comments. 1 byte can be mapped to ASCII and basically represent letters in the alphabet. And in C, if you want to declare a character, a single character, you write down the following. Char stands for character. Then you add in a name for the variable, and you assign it to a value. Now this is a single character. This is how you declare a variable. You specify the type of variable.
But what about name? I want name, so do ace. Right, ace.
Yes, we'll get to that. So, this is how you declare any variable ever. You have the type at the start. What type? Like, you want it to be a number, you want it to be a letter, you want it to be God knows what else exists in your program. You start it off like this. Then, you give it a name, like anything at all. It could be anything. Though there are some rules. Variables cannot start with numbers. That is illegal. It is not allowed to write down a variable that starts with a number. However, after you start it, you could just do whatever. As long as it's a allowed ASCII character that you use for the variable name, it's allowed. And basically, then you use the equals character, or basically the assignment operator, to assign it to a value. In this case, I assign it to the value of A, or 97 in the ASCII table. Also, could everyone please focus on class right now? Please. Aceuwa, Oz, eyes to the board, eyes to the fucking projector with the Visual Studio Code. Lunch break will be after we're done. All right?
Okay.
Good. So, and when you declare a variable, it always ends with a semicolon. I think it is a semicolon. This thing, basically. This weird symbol. Because if you don't, it basically, as the compiler is reading the code, it doesn't know where your declaration, where your call ends. It needs the semicolon. Here, alright. Good. Wait, why are you checking watch time, Oz? You want to see how much attention I am paying? Oz has spent 0 seconds watching. Okay, I see how it is. Alright. Class, please orient your fucking attention to the code.
Yo, I'm gonna tell the principal though.
Okay, you know what? Hey, Aceuwa, how do you declare a variable? How do you declare a variable? How do you declare a variable?
So first, you choose the type of variable you need, right?
Yes, the type. Yes, continue.
So you would press the enter button to do a new line to make it neat. So press enter. Yeah, good boy. Yeah. And then
don't call me that.
And then we go int.
Yes, integer is a type. The type of variable.
Yeah. And we go int a because it's illegal to start with a number.
Exactly, good.
Yeah, and then we do a semicolon to tell the code to like what you said, then like finish.
So basically stop, basically to create the variable. But it's basically how it works. You always put a semicolon to basically finish any command, anything that you're doing.
Finish the command, that's what whatever. You call it. Assignment, yeah.
Yeah. So this, you're right. Good listening skills, Ace. Even when talking to someone else, you're somehow still listening.
Yeah,
I wish I had that power. Anyways.
Yeah.
This is how you basically create a variable, the most simple way possible. But usually, it is good practice to always give it a value. Now, why do you think that is? Does it not default to 0?
No, because it can get some random access memory, which can give out bleh.
Exactly, that's right. If you do just A, and let's just say printf, we're gonna call print because we want to print out the variable. We pass in %i because we want to get an integer, and then \n, which is the new line character that is part of ASCII. \n is basically in the enter. When you press enter, this is literally what it does. It basically adds in a \n to the console. And then a semicolon to end the command. However, printf also takes in other arguments, which is what we call when we pass in something in this thingy. I don't know what they're called.
Was it %i or %d?
%d is for decimal. That's what the D stands for. But %i also works. Okay. But if we do this and we print out the value of A, it's going to be random garbage value. Literally. Like, look at this.
Aren't you meant to do and A, or is that just for scanning?
What do you mean and a?
Ampersand A.
No, ampersand A is to print out the address. We'll get to that. We're not going to touch that just yet.
Okay.
Be right back. Gonna have revenge attack. I'm gonna revenge attack the dude who attacked my Clash of Clans
Teacher,
village.
focus. Teacher, focus.
Fuck, what were you using my own powers against me, Potter? Anyways. Alright, but here's what happens. If you don't assign a value to a variable when you initialize it, you get this. Random garbage. You just do it again over and over. It's just a random number. It's whatever...
4, 5, 6, 3,
exactly.
2,
It's just
1,
random
4,
values that are within memory. This is just random stuff that is within memory. Because when you allocate a variable, when you just create a variable, that's what I mean. When you create one, it gets basically allocated in memory. And if you don't assign it a value, it's just going to be that little region of data. Whatever is already there, it's basically the value. Which is why it's very important that you always assign it a value. Because otherwise, it's just going to give you a random garbage.
Garbage.
Exactly. So, we talked about what a variable is and how to declare it. A variable is, you know, a value in your program that has a type of what it is, and you can assign it, you know, a value. Hence the name variable. It can have any value of the corresponding type. It has to be the right type, because if you assign, for example, a pointer, I'm gonna go ahead and show an advanced concept. Char pointer is equal to a. Wait a minute, I forgot to write that name. Blah, 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 whatever. It will not throw an error because C is a very, very volatile language. But this is a very horrible idea if you ever do this, by the way. But this is usually not allowed because it's not a good idea. If you code in C#, this will be 100% an error. So, let's talk about functions. So, the way functions are made or declared is the following syntax. It's almost very similar to variables. You first start off with the type that it returns. Let's just write down void, which means the function returns nothing. Void returns nothing, nada. Then we give it a name. Do something. For example, we give it a name. Then we put these character signs. I don't know what they're called. They're open braces, right? They're braces, right? They're braces. That's what they're called. No, bracket. Bracket is this. No, that's curly brace. This is braces, and this is a bracket. All right, I got it. So open and close brace, open and curly bracket, and done. This is how you do a function. Here you can basically do whatever, so on and so forth. You can do some calculation, maybe you're doing whatever. Let's just make an example like add. It takes in parameters, which is what you pass into the open and closed braces. For example, it takes in an int a and int b, and then it has as a return value also an integer, and you return a plus b. That's what it does. It adds together. So here, let's just say add 1 and 5, and then we print the value to the console to see if it did it properly. Percentage I, because that's how you say you want to print out an integer, and you pass in as the argument the variable. Compile the program and mint it out. See, it checks out. 1 plus 5 is equal to 6. And this is basically the most simple syntax of a function. Any questions so far, class?
No, sir.
Good. Now, let's get into lists, or what we call in programming arrays, or what the mega versions call it, basically. So,
wait.
Let's imagine.
What did I call it?
You don't worry, I didn't say anything important. So, imagine like this. You're creating, I don't know, an application that, I don't know, has like a list of numbers and it adds it all together and it prints it to your screen. So, for you to create a list of any type, instead of just saying int A, int B, int C, and assign it all a value and then print it out, you can instead create an array or a list in this case. So you declare the variable with int as the type. You write down the name of the variable, which is say here lists And then you put in an open bracket, and then you assign it a value through this by creating an open and closed curly brace. Like this. You write down 1, and it basically creates a list with 1 element. Or if you want more, you just add in a comma, and you do this. Like, you put in a bunch of numbers, whatever, and it's all valid, because, you know, this is how you declare an array, a list. But we call it array, so please map the thought that an array is basically a list of elements. And now, if we know exactly how many elements this array has, it has 9 in this case, we basically just do a for loop, which is, as the name implies, it's a loop. You declare it as the following: for, and then you declare over here usually an indexer. That's what we call it. But basically a variable that will go into the list. Like this. For you to access members of the list, you write down the variable, you put up a bracket.
Those are just random numbers you put in, right?
What do you mean random numbers?
Like, oh, do they mean something? The numbers in the list.
Oh no, the numbers are completely random. I just put in whatever for the sake of creating a list of numbers.
Okay.
So, for you to assign a number in the list, you basically put up a bracket and you index it through by putting in a number which represents where you are in the list. So imagine the list starts and we start with 0 because, you know, it's the very beginning. So when you start with 0, you're accessing 1. If you go forward, you put in 1, you go to 4. Then let's say you want the next element, you go to 2, and you're basically at the third. Wait a minute, shit, did I put in 1 again? You put in 2, and you go to the third element, because remember, we also count with 0. If you want to access the first element, you start with 0, the second with 1, the third with 2, and the fourth with 3, and so on and so forth. So if you want to access, for example, the last element of a list of 9 integers, we put down 8. And then we assign it to a value. Let's do here, for example, let's just say that the last element is now 4. And now we want to print everything. So we do a for loop, and we create the thing that will index, is what we call it when we, you know, we get an element from an array. We create an index, which usually name I. We can name it whatever even, but I for simplicity. I is equal to 0. It starts off with 0. And then it's going to loop while I is less than 9, which is the number of elements we have in the array. And then at the end of each loop, we do an I++. 100% destroy the village of this bozo. Oz, please put down your phone and stop playing Clash of Clans. We're having a coding lesson here, alright? Do you want me to call your parents? Anyways.
Ooh.
And now, for you to access a value, you write down list I. It's going to index into the list from 0 to 8. Because remember, this is the less than operator. It means that while I is less than 9, which means if it's equal to 9, it will break out. As long as it is less than 9, it will keep going. No counting parents. That's what I thought.
Semicolon in the list, like in the for loop.
Yes, you do need to have a semicolon because you're basically like specifying the parameters. Like, because this is literally just a loop. Because okay, here's how a loop looks like. While some like variable. Let's just say while 1 is greater than, you know, 0. Obviously 1 is already greater than 0. You know, checks out 1 is bigger than 0. And then it does this forever. While 1 is greater than 0, it will go on in infinity.
And
it will literally go, exactly, infinity and beyond. And what this is essentially you creating a while loop while creating an integer called I, which you equal to 0, and at the end of it, you always increase it by 1, or plus, which is basically I plus 1. That's what plus stands for. You increment the variable by 1. Mr. Teacher, I have a question. What is it, Oz? I'm waiting. could you imagine this would be an actual like class or just like taking 7 years to
Yeah.
say something? Have you had enough water? That's not relevant to class, so I'm just gonna continue. And of course they're gonna do that. All right. This is basically the fucking students throwing water balloons at the teachers, huh? Thanks, Oz, for the hydrate. I hope you also suffocate on water in your sleep, Oz. Anyways.
Damn, bro.
In a video game. Anyways.
Why is my teacher talking about video games? Kind of weird.
Anyways, so this is essentially this, but this looks way better, doesn't it? Like literally just 4 int I is equal to 0, I less than this, and I so on. So like I less than 9. This is literally it. This is called a for loop. It's literally this, but in one line instead of having to do this. Because, you know, imagine you have like 500 times like for loops and it would look horrible if this is how you have to do it. So.
The teacher does target you, Oz.
No, I don't. Because you're acting like a menace. What are you expecting? Anyways.
Oz is a class clown, confirmed.
Okay, so. This is how you do a for loop. And how you access an element is the following. Basically, it indexes it. As I shown earlier, this is how you access members inside of a list. Now, what happens if you go beyond it? Let's say you have this list is really just only 2 elements, and we're going like even beyond that. What happens? What happens? Oz, what? No, you know what, Ace, you've answered enough questions. Oz, what happens if you go beyond the list's number of values, beyond the limit of the list? What happens? Since you're paying so much attention to class. Error message? Error! You get a segmentation fault, which basically means you're accessing memory that doesn't belong to you. Like literally, like it will literally give you, in some cases it doesn't, because you know, C is very chill. But it is not a good idea to write into memory that you're not allowed to, because you can access another program's memory, and you could end up causing a crash, or even worse, just fucking breaking the entire system. But no, this is not allowed. What the hell? What is it? Okay, that's weird. But yeah. Guys, it's memory and stuff. Exactly what I said. Well, it doesn't print out a message to you. It just says segmentation fault. Like, okay, you know what? I'm going to show you an example of a segmentation fault. I'm going to show you an example. You don't need to know what's happening just yet. But here is an example. Wait a minute. Gotta quickly just include another library. This is what we call libraries. Basically, these include files, or basically this like... It's this collection of functions that you may need. And I'm going to include the standard lib, standard library. It's really what STD stands for. And stdio stands for standard input and output. And I basically access this library, which gives us the what?
What's the difference between STD and STDIO?
No, STD stands for standard. IO stands for input and output. STD lib stands for standard library. Wait, say that again? Say what? Anyways, I'm just gonna do here an example, and I'm just gonna do this, allocate size of this, and now I'm gonna access beyond the memory that I'm allowed. Like this is literally why it should throw you an error. P this is equal to this. This should throw you a segmentation fault. What the? Okay, I hate my life, man. I swear, the other day I got 500 fucking segmentation faults. What is this? This isn't allowed. Okay, you know what? Fuck this. Anyways.
Yeah, I'm kind of scared. Should we call the principal?
Okay, I'm sorry. I'm sorry, class. I got a bit angry. It happens sometimes, you know? It's like a middle-aged thing. Anyways. So where were we? We had a list of elements. You declare it as such with a bracket, and you'll give it values like 1, 2, 3. And if you want to access the values within the list, I don't. Oh God. So no, it's really 45. I'm not 45 years old. I'm not 45 years old. Anyways.
He's 65.
Basically, you act as members of a list, like so, and you assign it a value. And if you want to loop through all of them, you create this thing known as a for loop, or you create whatever means you have to basically index into the list through a number. So 0 acts as the first element, 1 acts as the second element, 2 acts as the third element, and so on and so forth. Now this is how you create lists. Now let's talk about sentences or words. As I showed you guys earlier, for you to create a character, or basically you want to see a letter, you start with char, you give it a name, like just say name, for example, and you assign it to A, for example. That's how you create it. But now here's the thing, we work with more than just one letter, right? Right, that's really how words work. So how do we do that? How do you think we do that, Ace?
With words.
How do you think we do that?
String?
Yes, a string, but there is no string. There is no string. Like, there is no string variable that you could do, you know, this with. What do we have to do?
Make a new variable?
Well, you're close, but no. A string is literally a list of characters. So what you want to do is create a list.
A list of chars.
Exactly. However, C has a more convenient way of creating a sentence instead of just writing like this. You know, this will be a pain in the ass, you know. Imagine you want to say hello and you had to, like, you know, do it like earlier. Like this. Like, you don't want to do that. This is annoying. So they have this other way to create a string, which is what we call a list of characters, which is through double quotation marks. And then in here, you write the word. And then you can literally just print it directly if you want to. Like this, you write in the format, which is S for string, \n, because by default, your console does not put a / and enter when you print out something, and then the variable. Like so. Now, we compile the program. Wait a minute. Oh shit, I wrote down print instead. It's printf. Printf for printing a format. If you just do print regular, it's not gonna work. Like this, and then main that out. And you printed out the string. Now, this is literally how strings work in C. You put in a bracket specifying that it's an array, and you give it a value. Now, imagine we know exactly how many elements we're gonna have in a list. Let's just say it's not a character like I just explained. Let's just say it's a list of ints again. Let's just say it's like ages. Let's just say we have like a list of ages from our students or whatever. And let's just say we know our class has 20 students. I know that's not realistic. It's technically just 2. It's just you and Oz. So let's just do an example and we have... Yeah, I'm pretty sure. The most empty classroom of all time. Anyway. So...
Can we eat snacks?
No. Just because it's the 2 of you, you're not going to eat snacks.
What the hell?
So
mean.
For us to create a list with specific number of values or specific lengths, we declare it like this. You put into the bracket the number of elements you want. Now in this case we have 20. So this variable has 20 spaces for integers. Only 1 student. I'm not paying attention. I'm gonna call the principal, Oz. This disrespect has gone long enough.
Who's the principal? Am I the principal? Can I be the principal?
You're the student! You're here to learn!
But you know how like the principal comes in the class to see if you're doing well?
Oh my lord.
I could be the one with the keys, like a jingle jingle, jingle jingle, jingle jingle, and then like
You've watched too many cartoons, Ace. You've watched too many
No,
cartoons.
that's what happens in my class.
What? What? The principal never checked up on our class. Hell, he only came in.
Yeah, the principal would come in and they'd be like, "Sup," and we'd be like, "Sup, principal," and then, yeah.
My word. All right. Okay. Okay. I'm gonna ask you. I'm gonna just ask you right now. I'm gonna question.
Huge.
I'm gonna question your knowledge real quick. Don't call the principal. I wonder if you're paying attention. Anyways. Ace, I'm gonna ask you a question. How do you declare a list?
By writing the variable and then doing the square bracket.
Yes, you create a variable the regular way, int var, for example. And then you put a square bracket. And you put in here the number of elements you want. Or if you want the compiler to do the work for you, you just put an open and closed curly bracket. And you write in here values.
Yeah.
It'll basically say, okay, I see, you have 3 elements. All right, 3 elements. So let it be. So let's talk a bit about strings. So let's just say we want to declare a string, right? Don't worry about the const thing. This basically means that the variable is constant. It is never going to change. It's a good idea that whenever something will not change in your program, you want to add in the const keyword to it. It makes it so the variable never changes value. Once it's been initialized, of course. So right now, let's create a variable. Let's call it name. And let's just say here, Aceuwa. So this is a list of characters, right? Oh shit, I put it in the wrong spot. What the fuck? I'm sorry. I thought I was programming in C# for a bit, because that's how you declare an array in C#. In C#, the programming language, C#, you put the bracket on the variable itself and not after the name. So here we have the string Aceuwa, right? Now, how many elements are there in this array? How many elements are there? 1, 2, 3, 4, 5, 6, 7. 7 elements. All right, that checks out. I mean, that's what would be in the list. Why does it say 8?
Because wait.
Why does it say that this variable is 8 characters long?
6. Because of a space.
Because no, there is no space in there. There is no space in the string itself. I know it. All right, Oz. What do you think it is? Teacher, I know. All right, Oz. I already see you raising your hand. Please speak away. The last element is friendship.
Real.
I mean, you're right about there being a last element, but no, it's not friendship, unfortunately. I wish most of my programs.
It's the quotation.
No. It's not the quotation marks. It's not part of the string.
It's the capital letter.
It's not the capital letter. It only
Jack
takes up
Bezos
one
has
space.
invaded the stream. Everybody brace for impact.
Alright.
It's a list empty.
Alright, Oz, you're getting an ad. Time out, ad for you. Could you imagine? Could you imagine
I
the
get the ad
teacher?
too.
Oh well, both of you. Okay, could you?
Ads, bro? I've been watching like 10 ads. I'm not even joking.
I'm sorry. Don't you have to do this when you're affiliate? Like you can't disable ads, otherwise people are gonna get, you know, what's it called again? Pre-roll ads. Because I'm definitely giving. I am sub.
I don't
Oh shit!
care.
I
I'm
forgot.
trying to watch through it. I like supporting through it anyways, but
Hey, thank you.
I just hate getting an hour of them because sometimes
Yeah.
it like my Twitch pauses and I have to reset the whole browser and it makes me watch like 10 more.
Yeah, fair enough.
And I'm like,
Yeah, no,
"Ugh."
you're probably the one of the top supporters of the No channel right now. Anyways, no, Oz is a sub, so that's why he doesn't get an ad. Anyway, so
Bro, I got
I'm
scammed.
gonna explain to you why that is. So imagine
underwater.
you what?
What? Okay, I'm back. Yay!
Welcome back, Aceuwa. So I want you to think about a world where you're trying to print out a string, right? Now imagine
Like an
you
actual
don't.
string from a printer.
No, a string like, you know, in the code. Imagine
Oh, okay.
imagine you have an array, whatever, but you know, you don't know when it ends. So
Yeah.
you're gonna go through each element forward and forward and forward until the string is over. How do you know that the string is over? Like, if you don't know how long the string is.
The semicolon.
No, 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 no. We're talking about the compiled program. May I remind you, once the program is compiled, none of this exists. It turns everything into instructions that your computer understands. Like, your computer knows how to print, how to write data, how to read data, how to write files, so on and so forth, but it doesn't know, like what is this? It doesn't understand this natively. It speaks only in zeros and ones. So I'm gonna ask, imagine it is going through, in memory, an array of characters, and it doesn't know how long a string is. Or imagine another scenario. Imagine you're trying to copy two strings. Like, imagine you want to copy two strings from one, like, their values from one end to another.
Like copy paste?
It's not possible. You don't, like, how do you know when the string ends? I mean, quite literally, you're doing basically a while true or something like that, and then you're just going through, you have your int I equals 0. And then I is equal to, I forgot to write the I bit. I equals to 0 and I plus plus. Well, my brain really is fragmented. So, and now imagine you're going through the name and like, how do you know, like, when to stop? Like, eventually you're gonna reach memory that doesn't belong to your program.
Oh.
Okay, imagine you're able to, you're God right now, right? Imagine you're God, but you can't exactly, just make random bullshit. You have to use the logic of your computer. What would you do to know when a string is over?
A full stop.
A what?
A full stop.
A full stop where?
What
do you mean? What?
afterwards.
Okay, but how?
Like a sentence.
Okay, but how will you mark a stop in a string? In an array of characters.
iPhone Oz. Oz speak.
Aceuwa. Aceuwa called Luigi. Oh yeah, also the true keyword does not exist. Oz, what would you do? What would you do? Imagine you're God. You can't make up bullshit, but imagine with the logic of a computer, and you can manipulate however you want. How would you define when a string, a word is over? How would you do that? How would you do that, Alice? Come on. We're listening. I'm here listening. There are no... Okay, there are wrong answers, but I'm not going to judge you based on it.
He's going to judge you based on it.
Nuh-uh. Nuh-uh. I'm not a liar. I'm not a liar.
That face says otherwise.
Shush. Anyways, Oz, I'm waiting for your answer. What? I can't say anything? Okay, what do you mean? Okay, you know what? Fine. I'll say it to you. So, in ASCII, as you remember, there are over 255 values. And what do you think they're, the alphabet is just 26 letters. And now imagine you're just, doing a case for, upper and lower case and some extra characters. Like, you don't need 255. Well, there is this ASCII element, this ASCII number called \0, which is what the computer uses to terminate a string. So you see that extra element, that is the \0. Or basically null. So when you go through a string, when you're printing it out to the console, or maybe when you're like copying from one end to the other, it usually checks if, this is how you declare an if statement, if something do this, if not to do something else. If name at I is not equal to, or let's just say it is equal to \0, this is easier. Then we break out of the loop. This is the command to break out of a while loop. And basically, once you're there, you're at the end of the string. They use this character, which is literally 0 in ASCII, the element 0, to be able to tell if a string is over. This is how it works. That's why when you declare a string, it usually has an extra element that your compiler adds, because why? Like, imagine when you declared a string, you wouldn't put the \0. Like, if you didn't, like, if you had to put it in, it looks like ugly. And if you don't, and if that compiler didn't do it for you, you'd probably get like 100 1,000 errors. So to break the loop, I just gotta do break. Yes, break with a semicolon. If you're in a while loop or whatever loop it is. Raise his hand. Alright, Aceuwa, what is it? I need a toilet break. Alright, fine.
And water. I need to fill up my water bottle.
I mean,
you can like keep talking about the list stuff. And like do revision time with Oz.
Alright then, I'll just revise it with
Yeah,
Oz.
give him a test. Yeah.
What do we do a test? Okay, yes, no one needs water. Okay, yeah, okay, yeah, thanks for the hydrate. Thanks for the hydrate. My microphone disconnected. Water the no plant. Bro, if I was a plant, I'd be dead by now. Alright, Oz. Again, I'm gonna ask you, how does a computer tell when a string is over? Repeat that for me, please. Repeat it for me. Also, can you just stop the loop end? What do you mean? There is no stop command. There is only, you know, there is break. That's how you break out of a loop. If you do it outside of a loop, it's gonna give you an error. There's no stop command. There is no stop command. When you're in a loop, usually you just, like, when you're in a while loop, while 1, in this case 0 and 1, or basically 0 is equal to false, and 1 is equal to true. So while true, let's just say, you know, if something, then you do break. That's how you break out of the loop. There is no stop command. What do you mean by a stop command? It's break. Break literally stops the loop. If no, fanboy... okay. What do you not get, my people? What do you not get about the C language? How long have I been streaming for? Shit, 1 hour? And then you gotta break to stop the loop. Yeah, you gotta use break to end a loop. There is no exit. This is not Python. There's exit function, but that does something else. There is break, which breaks out of the current loop. There is exit, in which you give in a code, which is basically it does basically this. It returns. It breaks the application. It returns 0 or whatever code you put in here, like 1, 2, 3, 4. And I'll explain to you guys soon why you need to, you know, write down a code. But that's how you break out of a loop. Now, I'm just gonna keep on talking about the if statement. Now, imagine you're checking some condition. Int a is equal to 3. Int b is equal to 5. If a greater than 10b, then, you know, let's just say we do something. Do something, right? Just do something. This is how you declare an if. Now, imagine this condition doesn't go through. Then you can write down an else, which means whatever, if this condition is not fulfilled, if a is not greater than b, then it's gonna do whatever it is in here. Will run if a is not greater than b. However, there is also something else. There is this thing known as an else if, which you declare like this. Else if. So basically, if the first condition does not run, then do this. Let's just do an example. Let's just say if a is equal to b. This is how you say equal. This is the equal operator. This is assignment. This is equal. So if the condition isn't fulfilled, then it's going to do the other thing. Exactly. However, right now we're talking about else if. So imagine you have multiple conditions based on the first thing you do. So imagine if a is not greater than b, then this is not going to run. So if you have an else if, then instead of just jumping straight to the else, it's going to check the next condition. And then the next one. And then the next one. Until eventually it realizes there's nothing else. And it'll run the else. Will run if any other condition is not met. Hence, the else. Else if everything else, you know, if everything is not done, then else just do this. So, have if A greater than B, then do this. Or basically, else if A is equal to B, so if it is literally equal to it, else divorce null. Well, good thing this thing's never gonna. Wait, is A? Give me a second. I gotta save my marriage. Here.
What?
Nothing. Anyways, we're talking about if statements.
Null's the boost.
So, welcome back, guys. So, we're gonna talk. Let's talk about if statements. So, if statements is essentially almost like a function, where within the no, is it bracket? No, it's brace. Within the brace, you want to do a condition. Write down a condition that will either equal to 0 or 1. 0, it will not run. 1, it will run. Like, literally, if you write down over here 1 and here 0, this will run, but this ain't. And if none of these two are met, it's only going to run the else statement. Because you could literally just put in, wherever it requires an operation, you could really just write down either 0 or 1. What if it's lazy and it doesn't want to run? Well, then the computer would be not doing its job correctly. It would basically be like the brainfuck programming language. Which, yes, that is an actual programming language. It's known as the brainfuck language. It is a real thing.
Unicode?
No, the brainfuck language is basically a language made by some fucking Swiss dude who lost his mind or something.
Oh.
Censored the word no. Oh yeah, shit, I said the J word. Fuck, okay, oh my god. Oh my god, that explains why I felt like my heart jumped for a bit. Alright, I'm sorry, I'm never gonna say the J word again. I'm sorry for, like, scaring everyone. I'm really sorry. Anyways. Never saying the J word again. I'm really sorry for that. So, what these statements care about is basically that a condition is met. That some condition is like, you know, if it's something equivalates to 0 or 1. Or you could even put in 3, 5. It doesn't care. Just whatever number. As long as it's not 0, it's gonna run. Because, remember, 0 in binary is literally just 0, 0, 0, 0, 0, depending on the variable you're even passing in. However, you can create these signals as conditions. Like, for example, for you to, let's just say you want this to run if A is lesser or greater than B or something like that. So let's just do an example. A lesser than B, it'll then run this. Or A is greater than B. Or A is equal to B. Or A is not equal to B, which you declare by putting a exclamation mark before an equal operator. So 0 is literally null. I do want to reach that part today. I do want to reach memory allocation, preferably. But, do you understand, Ace?
Yeah.
Or, you can do less than or equal to. Wherein, if A is less or equal to B, it'll run. And you can even create other conditions besides this one. Like, let's just say if this, do this, else if, do this. Now, it's important that you need to differentiate this. Because the else if will never run if this condition... Oh shit, I can't play this. This is copyrighted. This condition, if this is not met, or if this is met,
null is 0.
This will never run.
0 is null.
Yes.
Ace
But
is 1. I am 1.
I alone am the honored one. But yeah. So this is basically how if statements work. It has to either equate to 0 or 1. And this is basically an operator. You can even imagine this as a function that does the job for you to calculate either a 0 or 1
No,
value.
is Femboy confirmed?
So no, it's not. Please stop. All right.
We need to add cat ears to you.
Why?
I think cat ears would suit you. And a tail.
Okay. Okay, I don't know about the tail bit, but my word. All right. Okay.
We need to insert the tail.
All right now. Have you guys understood what you've been taught so far?
Yes, sir.
All right then. Then let's get dirty in here. Let's get real dirty. I'm gonna declare to you a string, but in a different way. Yes, please add cat ears to no. No, do it or I will do it. You're too lazy to do it, Oz. So it'll never happen. I'm gonna declare a string. And it's never gonna change value, so you know. Declare it as const. Then I'm gonna write down the type. It's gonna be a character. It's gonna be a string. However, I'm gonna put in an asterisk or a star. And then I'm gonna give it a name. And call it Aceuwa again.
Yay!
Now, this is how you declare the type known. Why are you working? Why are you working? You're literally. This is literally your fucking lesson, Aceuwa. Oh, fine, I'll wait. What the? Hi, Apollo Status. How you doing? No, do you want Chitamoa? Do you want Chitamoa? Why is his name so complicated to add carriers with AI swap? Okay, true that. I was kidnapped here by Ace. What? Real? Hell no. Damn. Damn. I actually just body double. It's just a fucking body double of Ace. Oh, that's kind of funny. Alright, anyways, I was about to get into a very important topic. I cannot continue it with Ace. C, nice. Yes, very good programming language. One of my favorites. Unfortunately, I only program in C++. I'm sorry, but I'm not going to continue this unless Ace is here, because this is an important bit. So you know what, Oz, a quick recap. How do you declare a list of some type? A list of, I don't know, numbers, for example. Oz, how do you declare that? Yeah, I got kidnapped here too. No promise me a bonus channel points if I pay attention. Oz, how do you declare an array? A list of elements of an integer, for example. Integer, which is just numbers. How do you declare that? Before we get into the nitty and gritty of it. Int bracket A. That's not how that's how you declare it in C#, not in C. That's how you declare it in C#. In C# you declare like this and then, you know, variable name. That's in C#. How do you declare it in C? I believe I was sick when you taught that. Like what, a couple of minutes ago? Very funny. Oz, please. How do you declare an array? Int A. Exactly, Apollo, but you forgot the semicolon, which is important. But yes, that's how you declare an array. Like this. Int, variable, name, and then in here the bracket. Though usually you have to initialize it. You have to give it a number of how many elements it's going to have. Otherwise, the compiler is going to throw you an error. Either that, or if you're not going to give it a number, at least assign it a value. Like this. Yes, exactly what Apollo said. Yeah, you're just taking fucking credit for other people's work, SMH. Now, that's how you declare a list. How... Now... I gotta ask, how does your computer know when a string ends? As you know, a string... We'll get back to this. This over here, we'll get back to it later. How do we... how does a computer know when a string ends? You declare a string as follows. The const is because the value is never going to change. Name 2. Remember, name variables cannot have, when you're creating new variable, they can never have the same name. Otherwise, it's going to throw you an error. White space. Exactly, it's a white space character, or the 0 character at the end of a string. Like, for example, here comes the word, and usually the compiler by default, sorry, I forgot to declare that it's an array. By default, adds in the white space character, or basically the zero whatever character, string ending character. However, many names. The mega virgins like to call it many things. But yes, that's how your computer knows when a string ends. Usually, it doesn't necessarily go by the length. When unless you already know it. So, white space. Sorry, typo. Okay, Oz, just because you and Apollo status share the same fucking username color doesn't mean you have to pretend to be him. Alright. Good. When's Ace gonna come back? Because this part's very important. Also, thank you, Apollo status, for the follow. Very epic. Very cool. Also, actually, I forgot to thank somebody earlier. Thank you, Unisiha, for the follow earlier. I'm sorry that I couldn't read it aloud. Alright, now, I guess since Ace isn't here, I'm gonna teach you guys the second best thing. So, we're working so far with, characters. Which is really just, numbers, but get encoded to a character. Like, you could literally assign a character a number. Which would, when getting printed out, it would get printed out as the character, representative character. 65 being uppercase A. Now, we have different types besides these. We have int, as I said, int, which is, for numbers. Mainly, just normal decimal numbers, nothing that goes like this. You know how numbers have like these little pointings? I don't know what they're called, I'm not a mathematician. You cannot do this. This is not allowed. Except my thing isn't sending me an error. It should be sending me an error. Why aren't you sending me an error? Wait, what? What the fuck happened? Why can't I write? Shit, it's dead. God damn it. WSL. There. Yes, a decimal, but you can't do this. Give me a second. Except it will do it, but it'll do this thing. Oh, just give me a second. Wait, was it ever main.out? What the fuck? Anyways. You can do this because the compiler does something for you. If you print out right now this variable with printf back %i, which is the format we want to basically pass in an integer, it'll just print out a 3. It won't print out 3.3. See, it's just going to print out a 3. Now, why is that? But we can use it if we use float. Exactly. Because then it supports the floating point numbers. Basically, the numbers that go below, 0 point. Basically, numbers with a point. I don't know how to I don't know the word for it. Alright, man? It's not in my mind. I use like floating points. When I say this, I mean like floating point numbers. Mr. Teacher here. What is it, Oz? What do you want? What is it, Oz? Well, do you have a question? What is it? But as you can see, we have different variables. Different types in this case. I'm gonna kill myself. Oh yeah, it's because I'm printing out fucking... forgot that I need to change it to an F because it's a floating point. Can I drive to McDonald's real quick? I hunger. You're in the middle of a class. Wait at least another hour. You gotta print out with the F, which stands for the floating point format. Now, if I print it out, it should be 3.3. Now, if you want, you can also write it as a double. A double is essentially a float, but it can carry like higher floating point numbers. Because eventually, your compiler, or not your compiler, your code does not know how to read anything beyond a certain point. Let's do an example. Let's put everything over here as 999999999. Now, if it's a double, it could possibly print all of this out. But, if you make it a float... I mean, I'm pretty sure... Maybe, actually, I think this might work. But I'm pretty sure it can't contain that much. Teacher still targets me, SMH. Now, for us to print out beyond just, the first 4 floating points, we do the following. Point, and then the number of cases you want to print. Let's just do 20 for now. If we do this, and print it out to the console. What? Why the fuck did it round it up to 4? Okay, you know what? Let's make it... it might be the other way around. Let me see if it works now. Come on, bro. I want to see the 9s. I wrote them there for you know what? I'll just make this... You know what? I'll make it ultra complicated on purpose. Alright, it's 9 and 9 with a couple of 3s in between. Now, if we print it out... I'm gonna kill myself. What the hell? Okay, usually what would happen... Let's just... Like that. Let's just print this out and see if it actually does what I expected it to. I guess it's kind of doing what I expected. Basically... Is it? Yeah, it is. It is. Basically, you know what? I'll just explain it to you. It's better if I'm not even showing it because it is actually the case. Ace, welcome back. Welcome back, Ace.
Thank you. Thank you.
So usually when you're declaring a float which can hold numbers like, you know, 0.5, 5.0, I don't know. Basically numbers, basically any number that has a, you know, a case like this, you know, dot, something, something. Usually your computer can't print out too much detail. Like imagine your float looks like this. Like literally like the only real value it has like at the end. Depending on the type of float, like let's say you call it a double instead, which is essentially like 2 times the size of a float, it can maybe carry the capacity to keep this exact number. But let's just say in a float's case, it can't. It'll basically give you garbage values. Because, you know, it went beyond the range of what a float can carry. Mr. Teacher, yes, what is it, Oz? Hello. Hi, Auntie Crazy on YouTube. How you doing? Stream Elements is using their phone. You know what? Stream Elements, you got a timeout. Go to the shame corner. Go to the shame corner. Did you? Can I actually time it out? I can actually time out Stream Elements. I get timed out.
Jeff Bezos.
Chat, Stream Elements has been timed out.
Everybody brace
Stream
for
Elements have
impact.
been timed out. SMH, how could you stream out? Using your phone during class, how could you? Anyways, Ace, let's get to the part where we're getting to, because we're gonna have to speedrun this. We're gonna have to speedrun this a bit.
Okay. How long
Alright,
time
Ace.
do you have?
No, I have time, but it's just, I prefer to finish this before 3 p.m.
What time is it now?
2 p.m.
Okay, I agree.
Alright. Aceuwa.
Yeah. I got hit with ads.
Damn.
And
This
it's
here.
2 minutes.
This is known as a pointer. A pointer is really just a variable that points to a memory address.
Yeah.
And what this is doing, I'm just going to explain to you what this line right here is doing, is it is declaring the variable name and assigning it to the array Aceuwa. No speaking to a woman? Shocking. Auntie Crazy, come on, please. That's not the point of the stream, alright?
Shock.
I'll show you an even simpler example. Imagine the following. You want to, as you know, every single variable on your computer, it exists in your RAM. Your RAM literally holds every single variable you exist. Like so. Right here we have an integer. And this integer named variable exists in your RAM with the value of 3. And as you know, memory has addresses. Imagine your memory. Imagine your RAM as like little boxes where a value can be stored inside. And every single one of those boxes is, let's just say it's like a number away. It's like a list of values that go up to gigabytes worth. And you can basically, and whenever you want to like go to a certain value, you address it. It's an address within memory. And this variable right here exists in your RAM. It has an address in memory. For you to print said address, you do the following. Printf %x for hexadecimal. It's something I'm not going to get into, but it's basically something similar to binary. I'm going to put here 0x because, you know, it's going to look a bit more clean. Dropping in to say hi, Vivo. Okay, now bye. Then why'd you come in here at all? Anyways. Printf percentage X for hexadecimal. We don't need to know what that is just yet. Backslash N because we want there to be a space. Now, we pass in ampersand. Ampersand variable. If we do this, it's going to print out the memory address of this variable. Like so. This is its address in memory. And now here's the thing. Here's a bit of theory. Your RAM is basically like a huge container of boxes, and each of those boxes exist at certain points in your RAM, and each of them holds some value, some variable to every program on your computer. Now, when a program starts up, when the compiler creates a program and then you run it on your computer usually creates two regions of memory. Or basically like some allocated region of memory. Two regions. The first one called the stack. The second one called the heap. Now then, why do you think the first area that your operating system, it allocates some region in your RAM for your program alone? Why is that first region called the stack?
Stack.
Why is it called a stack? Why do you think it's called?
Stack.
Yes, you're right, but what stacks? What stacks? Remember, in your memory, RAM, variables exist. They're values. So,
Yeah.
I gotta ask. What is stacking then? What gets stacked? Thanks for the hydrate, Oz. What stacks? Actually, I'm gonna make this easier later. I'm gonna change this. Exactly! In the stack, when you create a program, when you first initialize the main function, every variable you create without allocating dynamically, we're gonna get into that, gets allocated in the stack. And as the stack implies, it's literally your variables are stacked next to each other. For example, if I say int var2 or var1, whatever, and give it 5, it's going to exist right next to the variable. Here, I'm going to show it to you. We're going to print the address of var2, and they're going to be right next to each other. Because they live in the stack, because they were not allocated dynamically, they were allocated in the stack. And we're going to get into that. JCC may not see, and then... See, they're right next to each other in memory. So at address, let's just say your memory, right? Your RAM is a huge list of variables. And right now, these two variables exist at this index. And you want to know why they're apart like this? Why is that? Like, why aren't they like one index apart? Why are they 4? Why are they 4 apart?
Bits.
This is bytes. Remember, your computer mainly communicates in bytes. 1 bit is equal to... 1 byte is equal to 8 bits. So, why is it 4 bytes apart? Why? Why is that?
You tell me, Teach.
Oz, please. Anyone else? Auntie Crazy or Oz, please tell me. Why is the space between these two variables 4 in the stack? Remember, the stack is a region in memory that the operating system, your computer, creates for your program where all your variables get stacked next to each other. Right next to each other in memory. Why is that? Why is the distance 4? Sorry, I wasn't paying attention. I should give you the same treatment I give to stream elements.
Beating?
Am I ever gonna code? No. You know what? That's fair, Auntie Crazy. You're just like my you're like my mom. She's just looking in here. Yeah. I don't understand shit. All right. Indexing. Yes, but you're close. But why is it 4? All right. I'll explain it. Because the size of an integer is 4 bytes. Literally. Look at this.
That's what I said.
Is it? Okay,
yeah,
chat.
I said the bytes.
Yeah, no, but that's not like no. That doesn't specify that it's the size of an int. You should have said that. Otherwise, I wouldn't get it. But here.
But I said byte.
I'm sorry, that doesn't count. Size of int here.
Chat, let's overthrow this teacher. He's being mean.
Why you can't overthrow the teacher? No
Chat,
being, we're
let's call
probably
the
getting locked
principal.
in the basement again, SMH.
Yeah,
Yes,
let's
I
lock
agree.
him
Don't
up in the
agree!
basement.
What? No, it's the other way around.
Yeah. Why don't we lock him up in the basement, chat, and then drown him with hydrates?
Let's overthrow the
Yeah.
teacher. No, stop. Stop.
Yeah,
I
and then
am
let's
teaching a
steal his
lesson.
hat.
What? No!
Yeah.
Oh, do you know how hard it was to steal this?
Yeah.
Okay, it wasn't that hard. The dude was drunk. But it was so
Alright,
hard to
let's-
teach it.
Let's hydrate the teacher.
Stop!
Hydrate time. Wait, why the fuck is it on a cooldown?
Up, because it's global. Womp womp.
What the sigma?
Anyways, please pay attention
Remove
to
it.
clads.
I ain't paying attention if you don't remove that.
Remove
The-
what? I'm not gonna remove the
timer.
fucking. I'm not gonna remove the cooldown.
Well, womp womp to you, teach. You
You're gonna
remove
kill
that
me!
timer or else.
I'm gonna call the fucking principal. I'm gonna call the principal.
I am the principal. Do you want to
Okay.
get fired?
Then I'm gonna call your mom.
I'm gonna call your mom.
Fuck!
Yeah.
I'm not gonna remove the
Yeah.
cooldown. I'm not. I'm not
Remove the
even.
cooldown.
I'm not even logged into fucking Twitch on Google.
Log in right now.
No, I don't want to remove it.
Right now.
Bro,
See,
nobody.
even my
Nobody.
chatters know I steal moms and girlfriends.
Nobody.
Chat, do you guys have a girlfriend? Can I see
No.
your girlfriend?
Chat, please. Nobody has ever fucking overthrown this in the last year. I'm not gonna make you change it.
Remove the cooldown.
No. No, we're gonna
Remove the
listen to
cooldown.
the. Okay, what are you gonna do, huh? What are you gonna do? What are you gonna do?
What are we gonna do? Yeah, no balls.
I do not care. What are you gonna do?
No balls.
What are you gonna do?
No balls.
Can we please go back to the lesson? I'm trying real hard.
That's what all the teachers say. But
Do they?
But-
Do they? I
but
don't remember my
womp
teacher was saying
womp.
that.
my teacher
Okay,
did.
can we at least look at? Okay, can we at least? What?
Can we at least remove the cooldown? Oh wait, hold on. I got it.
Wait, what?
Got it. Hold on. Watch
No, I
this.
will
Watch
alter
this.
for you if you
Watch
aren't.
this, chat.
Don't disable the
Watch this,
cooldown.
chat. Watch
It's not
this.
too
Watch
bad.
this. Watch this. Watch this. Watch this.
What?
Include.
What are you doing?
The dot h. Right.
Why the fuck is it
Right.
negative?
Right. Chat. Right.
Oh, there it is.
Boom.
That makes sense. Oh, it's probably because
Right.
of the thing.
Oh shit. Dot
Why are you just
h.
Why are you just running
And
the...
then we go int main.
Uh-huh.
Right chat, and we go hydrate times 1,000.
Oh my fucking god.
Return 0 with a semicolon.
That's not how
And
that's not how it works.
close the
Let her
bracket.
cook. What do you mean? That's
I've
gonna throw a
literally
compiler
cooked,
error.
chat. I've
That
literally
would throw a compiler
Lessons over.
error.
I
No,
dismiss
it's
class.
not.
We
No,
win,
you're
chat.
not. No, you don't.
P1 W
Oh my
in the
fucking
chat.
god. Can I please continue?
W. Yeah, of
I
course.
was literally about to fucking explain why the offset is for. Okay, look at this. If we look at it, the offset between one variable and the other is literally 4, because the size of an integer is 4 bytes. And because they're in the stack, they're right next to each other, and the offset, hence, being literally 4 bytes. For example, if I declare over here, let's see what I can. I think it's called an unsigned long. This creates
Why is it a
an
long,
8
long?
because it's a variable that can hold very long values. Like
Oh,
this
you can
could.
just write that?
Yes, I don't think you can do it 3 times though, or maybe you can. No,
Oh.
you can't. Oh well, long variable. This variable here should be 8 bytes or maybe even 16 bytes. Let's just say it's equal to, I don't know, let's just put it to, no, 2,300. Now, if we print out the size of unsigned long, and we print out this variable in memory, printf, %i, \n, and we put in here the long variable, and don't forget, we gotta put in here the ampersand to get the address of the variable. Compile the program, and here. The size is 8 bytes, and as you can see, 8 plus 8 is equal to 16, so it jumps after the second variable. See? It makes sense, because it's its size. as I said, in the stack, they get put together. Now, let's talk about what the heap is. Now, so far, as you know, we've been creating lists like this. Int list 40. 40 elements, right? But now imagine, let's just say we're creating a list for like, I don't know. We're trying to store here like ages of like 40 people, for example. But imagine we actually want to store 50 and the program doesn't know that. How do we allocate it? Like, how do we get that memory? How? Like, it's not, you can't just do this. You can't just pass in size equal to 430. You can't just do this. Because it will give you an error saying the expression must have a constant value. Because basically, the compiler needs to know, once it's compiling your code, the size. If I've made this const, then it should work. It's already constant, it should work. Expression must have, you know what? Yep, literally works. Anyways, if you declare it as constant, the compiler is like, okay, the variable size will never change. So I can just literally pick up this and copy and paste it in here. It will never change. So I know the size of compile time, but how do I make it dynamic? Like, this is shit. So there is this concept known as dynamic memory allocation. So
I've heard about it.
Exactly. When you create a variable, the compiler automatically, you know, allocates it for you in the stack. You know, it's right next to each other. It knows where it is. If it ever wants to access a variable, it just has to look at the list of variables that exist and, you know, use that value. But if you wanted to create a custom or like a variable that you allocated yourself, you need to declare it as an address. This declares an address variable or an address of type int. No, can you watch the video and tell me if this tutorial was valid? If it's a fucking rickroll, I'm gonna time you out. I do not care. If it's a rickroll, I'm gonna time you out. I do not care. I'm gonna open it up on stream. If it's a rickroll, I'm gonna... Well, I guess he... he timed himself out. Oh, the mouth. Okay, worth it. Anyways. So, when a pointer is literally a variable that points to an address in memory. Imagine it is literally an int. Imagine this is literally an int into a list. It's basically the address of an element that you want.
Can't stop me from speaking THO3.
Yeah.
No, whatever. So, the declaration of a variable is literally int star, and then you assign it to a memory address, or you assign it to a number. Now, why a number? As I said, the pointer is really just an index into your memory. Literally. So you can really just give it any value, because this is a valid index into the memory. However, it is usually good practice to, when you don't allocate the memory yet, when you haven't allocated a space for it yet, you assign it to null. I rest my case. Anyways, you assign it to null, which is basically the memory address 0. Now, the reason why, it's because imagine your compiler accesses this area in memory, and it has a random garbage value. It'll access memory that doesn't belong to you, and it'll cause an error, or a segmentation fault in this case. So, for you to allocate memory, there is this function known as malloc, memory allocate, which takes in as a parameter, because it's a function, a size in bytes.
Have to be a garbage value?
No, it doesn't, and it shouldn't be a garbage value. But it'll always be a garbage value if you don't give it a value when you create it. So here, I basically allocated a variable that has exactly 1 byte, or basically the size of a single character. However, if you want to allocate, let's just say, an integer, you write down size of int, and it allocates you the size of exactly 1 integer. And remember, whenever you dynamically allocate a variable, you have to free up the memory. Because otherwise, that variable is still going to exist randomly in your memory. And it's never going to get touched again. It's horrible practice to keep around. So you always got to free up everything you malloc or calloc or whatever memory allocation function you use. Do you get it, Ace?
Yeah.
Alright then. So, as I told you at the start, there are 2 regions in memory in your RAM. There is a stack, which goes every variable you create that isn't dynamically allocated, and the heap, which is essentially this random region, this huge region, where whenever you allocate a variable, the values get sent over there. Like, whenever you allocate, it is random. Literally, look at this. Printf, percentage, wait a minute. Percentage I, because we want to, we want to print out an integer, though you could put in hexadecimal, so you don't get, negative numbers. But you percentage I, you put down percentage I, and you write down variable. Remember earlier, ampersand gives you the address of the variable. But since this is a pointer to an address, it is literally already an address. Like, if you do this, for example, int to a var, whatever, just name it var and give it 3. If you do var ampersand var, you're literally accessing the region of memory of the variable. So, let's print out the region, or the memory address in this case. See, it's random each time. And if you declare, let's just say you allocate again another variable. Let's just say variable 2. They're not going to be right next to each other.
Mr. played text to speech for a bit. Does it have to be a garbage value?
Mr. Oz played text. Why did you copy and paste your message twice? Does it have to be a garbage value? It will be of garbage value when you initialize it. Did I? Oh, bro, I didn't even, bro, you know what? Bro. Doesn't even know how to write, by the way. So, now we have 2 pointers, and they're both dynamically allocated. Now, let's print out their memory address. Now, if you look at it, they're in 2 completely different locations. See, this one's in, well, I'm not going to read all of that out, but it's basically at 136. This one's 168. That's the region of memory. It's like a huge offset between each other. Now, this is the difference between dynamic and, I guess, static memory allocation. Static as in the compiler already knows what the variable is going to be and how much there's going to be. Now, as you could have guessed, let's just create an int and call it a list. And now, let's just say I want a region in memory that contains 7 integers. So we call malloc size of int, because we need at least for it to be the size of a single integer, times 4. And remember, you always free up the variable at the end if it's dynamically allocated. Now, we've basically created a list of integers. Literally. Now that we allocated it, we know that it's 4 in size. Let's do 4 int I is equal to 0. I less than 4. I plus plus. And list I is equal to 0. Let's just say, actually, no, let's equal it to its own index. Now, let's do another for loop and let's print out those values. Oh shit, oops. And yeah, let's just print it this time. Printf value at index percentage I, because I want to print out the index, and then I want also there to be another value. Now here you pass in the first and the second value you want to print out. Now you compile and you run. And I forgot the \n, so it's all together. Oopsie poopsie. Happens to the best of us, trust. Here. Value to index 0 is 0, value to index 1 is 1, and so on and so forth. Because we literally set it up earlier. Now, what happens if we go beyond it? Like, let's just say we go 5. Hopefully, this thing's going to throw me a segmentation fault like last time. Wait a minute, I think I know why. It's because we're... Wait a minute. We're probably... This is probably not in debug. This is probably in release, so it doesn't throw you the error. Bruh. Bruh. It's okay. If let's just say we do it this one normally, but then we print out the next value. Let's just say over here we go beyond the range, and over
トラス
here
ト
we don't.
TUSTTRUST
Trust, does trust us. Leave the brain rot for another day. But yeah, basically this is dynamic memory allocation. So as you can tell, the address of list, for example, let's just say we want to print out the address. If you look at it, it's literally going to be right next to each other because we allocated 4 times the size of int in one call, so they're going to be right next to each other. Look at this. They're all right next to each other with an offset of 4 here. It goes from down and up here. 2, 6, 10, then, you know, 5 goes to 50 goes to 60, 64, and 68. Right next to each other. And here's the thing. This is exactly what happens with arrays when you initialize them. Let's give it like 4 values. Like 1, 4, 6, and 8. Right now, this list has 4 values. So now, we print out their memory address, which is right next to each other. Shit, wait, sorry, I didn't read that. Oh, shit, we're freeing it up. We shouldn't be doing that. We don't free out statically allocated variables. Hey, so
Yeah,
you
I'm
awake? That's what I was wondering as well for a bit, honestly. Right here. If you look at it, they're right next to each other. Do you understand? A list is really just a continuous address of values right next to each other. That's literally what it is. And when you allocate it dynamically, or whether you do it statically as in the compiler knows already what you're creating, and it's not, you know, hey, I pass in this value, I read it in, then I pass in there. It just already knows, then it's static. It's dynamic if, as the program runs, you allocate it. You get it?
ERB Need some cookies can't live without M.
Alright, you know what? Hey, Ace.
Yes.
How do you allocate memory dynamically? Is it gonna be a series of streams or a single stream? Single stream. So I'll probably be helping Ace off this off screen.
We can do series maybe, but not like every week. Whenever we find this scheduled time.
Oh, might as well be never. Anyways, Ace, how do you dynamically allocate memory? Please tell me how. I have dementia. What do we forgot?
JD. How do we do it? I found JD.
Nobody cheating. Hey, Aceuwa, how do we do it? Remember what I said. First and foremost, you declare the
List.
type of variable it's going to be.
Yeah.
You
Type
add
of
in,
variable.
yes, for example, whether you're allocating an integer, a float, a character, whatever it is. You create an int, you put in an asterisk. This means it's going to be a pointer. Then you give it a name, let's just say PTR for pointer. And then you call a method known as memory alloc of the standard library, like so. Malloc, which means memory alloc, and then you pass in here a size. Hell, you could even just say that this is of size 1. It is valid. We shall see. Alright, Aceuwa, how do I create a list of integers? How do I do that?
You do the variable.
I create a variable, yeah. I'm gonna
And
actually I'm
then
gonna do
we
it.
do-
Int variable, alright. Am I missing out on anything?
Hold on, I gotta wait for your stream. You're forgetting the square bracket.
Okay, but what if I want to dynamically allocate it? I want to not. I don't know how long the list is going to be. I'm gonna find
that's
it out
okay.
as I'm running the program. So how
That's
long?
okay, it's
So
still
how
the
do
square
I?
bracket.
So how do I allocate it?
Still the square bracket.
All right. Now what?
Equal.
Equal to what?
Curly brace.
Right. Now what?
That's it.
Alright, so you tell me this is going to run.
Semicolon.
Yes, you never forgot that. Okay, is this going to run?
I have no idea.
Damn, it is surprisingly. It's probably just an empty... Okay, then now... So, how do I know how long this list is?
You could put a number in there.
Okay, but what if I want to, know it when I'm running code? Let's just say here I want to...
F.
In size, let's just say it's 0 for now. We do scanf, which scans the input from your computer given a parameter. And then we pass in here the memory address of size. Because we want to write to it. Alright, cool. Now, how do I... So, I just got to put this in here and it's going to make the size automatic?
Yeah.
Really? Alright. So, it's going to work.
I hope so. Maybe I'll have to sacrifice you.
Why the fuck is this working?
Because I am a god.
Oh wait, now I know why. Wait a minute. I know why. The compiler optimized it, probably. It must be. Otherwise, this is actually just like, treading on the fucking landmine. Garbage valves, missing const. You can't write to a constant variable, though. You can't do that. Here. You can't do that. No, more like fired teacher. Okay, buddy. Okay, buddy. Just so you know, I work mainly in C++, my guy. Now, let's just print out the... So, I'm gonna... So, you're telling me that variables... the variable is gonna be this size.
Jeff Bezos has invaded the stream. Everybody brace for impact.
It did not allocate it dynamically. Bro, am I actually programming in fucking C right now? Bruh.
Yes.
Bruh.
Bruh.
I mean, for starters, your compiler does kind of clean up stuff for itself. Anyways, generally, you're wrong. This is not how you dynamically allocate. You declare int start, which means it's a pointer. Then you call malloc. Let's just say you want 5 integers. You write down here size of int multiplied by 4. Now, let's just say you want to, make it more, prettier, right? So you write down printf size of variable or variables, whatever. And then here we put in, it's going to be our input. Then we scanf. We create a variable called int size. We put it to 0. Percentage I, because we're going to read in an integer. And then, we put in here the variable's address. And then we multiply this by the size. And remember, when you allocate something dynamically, free up the pointer. Ahem, redeem above. Okay, Oz, I get it. I get it. Alright. So here we have a dynamically allocated pointer. So here now we do a for loop. We go through the size of, or basically the number of elements that we're going to have. And we're going to, assign them a value. Or if you want, you can also use this very useful function called memset. It's not here. Okay, give me a second. Maybe it's in a different include. Memory.age. Yeah, I already drank water.
I didn't.
What? You didn't hear me? What? Womp. There is this memory function called mems. Are you serious? Pointer, and then you add in a value, and then you put in here the size of your variable, which is basically size of int multiplied by size. Now, if you print out the values, printf, percentage I, we put over here the pointer, then we address it to the I, and then we print it. And test that out. Size of the variables, let's just say we want 4 elements. And they're all 0, because we set it to 0. Can anyone do the auto 4? I want to see it work.
Oops.
You know, yeah. How? Oops! It is literally my chat. My lord. Just so you know, that shit's expensive.
I know. I looked at it. I couldn't redeem it.
I'm just expecting it now. Yeah, he wants to do it when I least expect it. And even then, I am constantly pressing Control S, by the way.
What is... Oh.
But okay. This is how you allocate dynamically. This is how you set a value to a variable.
I just want to see if it times them out or if it...
Now, I'm gonna show you something cool.
Okay.
Int list. Remember how we allocate a list? We create that list, open curly bracket, then we put in here the values, right?
Yeah.
Now, remember how I told you that they're right next to each other in memory? That is literally the case. If I do this, look. For int I is equal to 0, I less than 4, I plus plus. Do you want to know that you can also index them in a different way? Like this. Printf, percentage... Oops, forgot the string part. Percentage I, backslash n, list, plus I. Now we encapsulate it. We put it in a bracket, or whatever, open brace, open close brace. And we put in another asterisk, which means we are accessing the data at that address. Also, I think it can time me out for 2 weeks if I'm unlucky. Oh yeah, it can. It's probably for a day. It's actually for a day. Anyways, look at this. It's literally printed out the val... What was that?
My phone fell.
Damn, it's so over. Oh, well, it's a Nokia brick phone, right? It should be fine.
Oh yes, totally.
Okay, look at the console output. Even though I didn't do the usual list I,
5, 7.
it's because literally I am accessing this data given the offset of I into memory. I can't live without your stream, null. Just kidding. Okay, have we just defaulted to being mean now? I think we are. Alright, you know what? No, I'm not gonna do this. Too much work. Not worth it. I can't live without annoying you every day. Fuck me.
That is so cute.
Anyways, this is how memory works, how your computer works. C is a very powerful language. Really cool tool. Now, let's talk about another concept. Data structures! Epic! Right? You know what data structures are?
No!
You don't know what data structures are? Well, we're gonna get right into it, and guess what?
That.
You wanna guess what we're gonna do? I'm gonna make it brain fuck you.
But we only have 9 minutes left, sir.
We only have, wait, what? Oh shit, really?
Yeah.
Well, then let's speedrun this. First, for you to create a variable, usually you start with struct, or you can write down typedef struct, because otherwise, when you create an instance of the variable, you have to write down struct as well. So let's just do this easy way. Typedef, I am defining a typedef of the structure. Let's just call it a node. And remember, when declaring a variable, you gotta put a semicolon at the end. When declaring it. You see, she understands it. For real, for real. If you need help off stream, just tell me. Now, in here you declare basically anything you want. You can say that this variable takes in a float, which let's just say it's, I don't know, seconds passed. I don't know, just calculate some sort of seconds. Int, which I don't know, maybe it keeps some sort of size in this variable. Now, I'm gonna show you something cool. There is this other data structure. Not data structure. There is this paradigm, or basically type of list known as a linked list. It's basically the following. I declared... Wait a minute. Do I have to... Node exists. What the fuck is this thing on about? I'll just declare it over here as well, because that's also a way you can declare it. So, what I did here is I created a structure that has a float with seconds passed and in size, whatever you need those variables for. However, it also has a pointer to another structure of its own kind. Now, what you can do is basically create this infinite list that goes down the structure known as node. So now to create a variable of the type node, you write down node, the variable type, and then you give it a name. I'm just gonna node. You know, I'm very creative. I know. And then semicolon. Now let's just initialize it real quick. Node.next is equal to null, because we're not gonna have a next location yet. We're gonna set node seconds passed equal to 0, 0 seconds have passed. Node.size is equal to 4, or let's say size of node. 5 minutes left, nullers. I have a name and it's null. It's not nullers, but thank you, I guess. Better than being called a fanboy, I guess.
What?
Aceuwa, are you still alive?
Yeah.
Alright, now let's just do the following. Let's allocate the next node. Malloc size of node. Now this allocates the next node down the list. And you could really like make a very complicated data structure with this. It's interesting.
Mm-hmm.
Fanboy doo vivank. You know what? Class, you're dismissed. You can go to break now. I'm gonna be ending stream. Fuck this. There's just no point. Aceuwa, I think class is over. Classes are
Already?
over.
But we had 5 minutes.
Does the 5 minutes make any difference? Probably not.
Okay. Well, thank you, teacher.
I gotta ask though. Did you learn anything though? I taught you the zeros and
I feel like
ones,
I did.
computer science. Okay, you know what? If you ever need help, just fucking write to me. Just
Yeah, will do.
C is like a simple programming language compared to most.
Yeah. This is fun though.
Yeah,
I don't know
but
about the back rooms, but
well, come on, it's very cozy in here. Trust.
can I be big
live
on
in
your
Super.
stream? Can I just stare at everyone quickly?
Oh, you wanna
Can I
like?
be huge?
You want
wanna
me?
be
You want me to make?
humongous.
Oh, you wanna be humongous?
Yeah, make me
Alright.
stare. Let me stare
Alright.
at everyone.
Alright.
Ready, chat? Ready?
Alright.
I'm gonna stare at you. I'm gonna stare. Look, chat. Do you guys see him? He's floating up. Okay. Trust. So, today, chat, we learned about C. And, yeah. Yeah. I'm the principal, by the way. But,
She's lying.
I'm not lying. I'm never a liar. But
Sure.
don't worry.
Anyways. Back to small.
Your teacher will come back to school.
Back to being small. Next year.
No!
Next year. Next school year. It's already summer. It's summer vacation anyway.
Bro, I was doing a principal speech.
Alright, fine. You'll get your speech then. Fine, there. I'll make you even huger than before. Alright, say your speech, principal.
Oh,
Well, you know what? Do the outro. Do the outro for me, please.
can
My
you get
lungs
me
are
my
bad.
outro music? Can you do the outro music?
It's already playing music. It's just it's very low.
Is the outro music on? You know the outro music?
Yes, music is on.
Music is on.
Yeah.
Chat, it has been a pleasure meeting you. I love you, chat. I'll see you, chat. I hope to see you soon, chat. I hope to see you soon. Get it? Sorry. C language. Yes. Bada tis, bada boom, bada bing. We're gonna steal Mel's hat and then we're gonna put him in the basement and like hydrate him.
Anyways,
Yeah,
make sure
we're gonna hydrate
to like and subscribe on YouTube. Follow Aceuwa on her socials. They're all in the description. Epic stuff. Good shit all around. Thank you, Aceuwa, so much for having me. It's been so long. Anyway, thank you guys so much for joining, and I'll see y'all next stream.
Bye.
Bye bye, everyone. Bye bye. Bye bye.